Hi all, this is Vikas from Best Price Trainings. Let's have a quick demo of big data, its challenges and concern solutions. So first of all, let's check about what is this big data here. So if we are talking about big data, let's understand something about data. What is this? What is the sole purpose of this data and how we can differentiate it in current scenario. So we can define data into two types. It may be a structured data or that may be the unstructured data. So the structured data is one that have a definite architecture that can be stored in rows and column format. Just like we have our tables which are stored in Oracle or SQL Server databases, we have Excel files, right? Similarly, instead of unstructured data, it do not have any specific architecture, and also like we cannot store them in the form of rows and columns. Just for an example, something like emails, something like documents, something like audio or video files like that. So as per the current scenario where we have a lot of social media sites, e-commerce websites, our messaging tools and all, the growth of this unstructured data is something like out of total data, around 80% of the data is unstructured. Moving forward, the most important point to consider over here is how we can identify that whether the given data is actually a big data or not. So there are three key parameters related to this. First one is the data velocity, volume and variety. So let's have a quick idea about all of them one by one. Data volume relates to like how much data you are going to store in your storage devices, right? So if we trace some years back, like we have data in KBs, then we move to GBs, and now around terabytes of data is very common today, right? You can consider it as a very kind of historical options. We can check it out for that. It is something like that almost during our school days or something like we used to carry floppy disk, right? Just a few kilobytes only. But now hard disks of terabytes are very, very common today, right? This is only because of huge amount of data that we are storing in our current scenario. Then we have something called as data variety. So again, let's trace back to around 10 years before today's date. We used to have a Nokia 9910 type of mobiles, and we used to send text SMS to our near and dear ones. But right now, sending the videos, sending the audio files, sending the photographs through WhatsApp or Viber or whatever is very, very common today. This trend shows the variety of data we are dealing in our current environment, right? After that, it comes to data velocity part. So initially, at the starting of this IT industry, we have batch processing kind of environment. We have some data, we can process that data in some non-business hours. But now the situation has been changed and we need data on a real-time basis for better prediction and for the better usage as well. Okay, moving forward, like something about veracity. So in our previous slide, whatever we have discussed is something about the data. Now we know that we have to process the data to get some business outcome. And who will be doing this task? This will be done by our application. Its application can be a e-commerce application, it can be a social media, it can be kind of online shopping or any type of like that. So the thing is like we need to analyze some data and to get some business value out of that data. It is something called as veracity. So let's take an example of e-commerce here. So let's say for the first time, if a user logs into the e-commerce website, he might see a lot of different projects like clothes. He might see computing items. He might see some kind of shoes. He might see some kind of a sports item and so on. Let's say he chooses a laptop to buy from an e-commerce website. It may be a Flipkart, it may be Amazon, or it may be something like that. So once he chooses this laptop, he just paid the amount for that through the credit card or debit card or whatever. It get delivered to his doorstep within 3 to 4 days. He checks that laptop, everything is working fine, and now again after 1 or 2 weeks, he opens the same website, he logs into the same e-commerce website. Then what will he see? He will see something like of kind of these products, like product you may be interested in because he has just purchased a laptop a few days before, and then these are the products which are related to his last purchase or last to last purchase, whatever, and he may be interested in these products as well. It's just a kind of direct advertising over there, right? So this is called as veracity to decide the business outcome based on the customer trend on that, right? So now, the most important point we need to understand over here is like you are not the only person who is going to use this e-commerce website. There are millions of users around the globe who are using these e-commerce websites 24 by 7. Okay? And so, this is the main scenario wherein we have to store that data and process that data at a very fast rate. And now due to this, kind of a lot of e-commerce websites, lot of these social media websites and all, the thing is like we have we have witnessed exponential increase in the data, whatever we are dealing with in our today's environment. Okay, so moving forward, some challenges related to this big data. It is something called as either data storage or data manipulation. Now you might be wondering that these are the challenges we have already faced a few years back, and we have got some solution also for this. But the thing is like, if I'm talking about data storage, this data storage should be economical, okay? And if I'm talking about data manipulation or data processing, it should be lump sum around real-time basis and should be faster as compared to our current technology, okay? And fortunately, both of these challenges can be easily addressed by Hadoop. Okay, so let's move forward and have some introduction to Hadoop over here. So Hadoop is basically your open source software framework. Now, what is this framework here? Guys, first of all, just keep this point in mind that Hadoop is not at all a programming language. Hadoop is not at all a database system. Hadoop is not at all a data warehouse or data storage or something like that. This is basically a collection of different technologies which are supposed to deal the challenges which are associated to the big data. This Hadoop consists of a programming language, this Hadoop consists of a database, this Hadoop consists of a data warehouse, migration technologies, like your kind of various analytics scenarios. Every options will are available within the Hadoop environment. So that's the main reason it is actually called as a framework. Okay. So this is deployed over the self-healing commodity hardware. This commodity hardware are a very low cost, very cheap computer system which makes this Hadoop deployment a very cost effective. Okay, so it's designed to parallelize the data processing across the computing nodes, and this way it just increases the speed or the processing speed of the system. A lot of these points are, guys, I'm just giving a glimpse of the same, and we will discuss them in our detailed training environment also. So this Hadoop can be able to detect all the concerned changes. Whenever there is a failure, Hadoop will detect it and correct it accordingly. You need not to go for any specific interference or something like. No human interference is required. Only to whenever it is required to plug a new hardware or plug a new server or something like that. In that case only, human intervention is required. Otherwise, nothing is required on that. Now, as we know very well that Hadoop is basically used to address the challenges of data storage and data processing. So there are two important components of Hadoop. These are your Hadoop distributed file system and MapReduce engine. Your Hadoop distributed file system is basically a storage structure, and MapReduce is basically a kind of programming methodology. Okay. Always remember that MapReduce is not at all a new programming language, but this is basically a programming methodology. You can realize this MapReduce using any of the programming language like Java, C++, C Sharp, or something like that. Okay. Moving forward, if we check the high-level architecture of Hadoop, high-level structure of Hadoop over here, so this Hadoop consists of two parts, as we have already seen in our previous slide. It consists of a DFS and it consists of a MapReduce. Okay. So now a DFS consists of a name node, data node, and MapReduce consists of a job tracker and task tracker. Now, guys, very important point here. Kindly do not confuse with the word node over here. Okay. These data node, name node, job tracker, task tracker are basically the services which are running on the Hadoop cluster. Okay, these are the name of the services, or you can also call them as a daemon. Daemon. Daemon means, like, as you might be aware that there are some background services which are running on the Windows system. So the background services which are running on the Unix environment are called as a daemon here. Okay. Now, guys, one more point I would like to share with you that Hadoop is supposed to install only on the Unix system as of now. Okay, it may be the market rumor or something like that that the new version of Windows which is coming to the market is compatible to Hadoop or something like that. But the most stable version of this Hadoop are supposed to be deployed on Unix systems only. Fine. Now you might be wondering that in this case you have to learn Linux first of all, and then only you can go for learning Hadoop. If you have idea about Linux, it's very good. But if you do not have any idea about how to write Linux command or how to work upon Linux environment, in that case, in this training only, we will take care of all these concerns. Okay, so if you do not have idea about Java or if you do not have any idea about this Linux environment, even then you need not to worry about that. All these parts will be covered in the training environment, detailed training environment only. Moving forward, if we check out the high-level architecture of this Hadoop environment, so it consists of basically it consists of two different layers. One is your DFS layer, that is the Hadoop distributed file system, and another one is a MapReduce layer. Okay. So in the figure, you can see that in a Hadoop cluster, we have a master server and we have two different slave servers. So as a mandatory part, a master server should contain name node and job tracker. Okay. However, in case of slave servers, it is only data node as well as the task tracker. Now, always remember a few points here, that data node and task tracker should always appear as a pair here. Okay, it should not be something like that. You have installed Hadoop on one server, you haven't installed task tracker, you have at DFS only. It's not like that. If you have stored at DFS, there must be task tracker as well. Okay, this is optional. This is only optional, not mandatory. This is optional, that you can keep your task tracker and data node on the master server also. Okay, so this is how we can plan to design our Hadoop cluster. This job tracker will be interacting with all the concerned task tracker, and name node will be interacting with all the concerned data nodes. Okay, so that's about basic or DFS high level architecture. Moving forward, like how we can manage this kind of data within our DFS, because as I told you that in our previous slide, that we will be using commodity hardware, all right, that are low cost computer system. So what will happen in case of a 24/7 environment where a failure of a single server will be very disastrous actually. So in this case, what we used to do is, like, our data will be stored in the form of data blocks, and these data blocks will be replicated across different data nodes. Okay, so once we go for the detailed training environment, in that case, we will study about the basic architecture and working of these data blocks and name node, how this is interacted with them, and how we can deal with the kind of data reading and data writing process as well. Moving forward, something about MapReduce. Now, guys, let me give you a small situation over here. It is something like that. Let's say you are writing a program. Okay, you are writing a program here to process some data which is present in your system. So what will happen? First of all, this program will load the data from the where it is from the system where it is already existing. It will load the data from there, and then it will, once the machine get the data, it will process that data and send it back to the original location. Okay, so this is what we were doing so far. But the thing is, right, guys, that now we are dealing with big data. Okay, and if we have to copy this huge amount of data from one location to another location for the processing, it will be very network extensive operation. Right? This will block your entire network for a very long time until the process gets completed. But in case of MapReduce, instead of data movement, program movement takes place. Okay, so it's something like whenever you write a program, the entire program will go to the data source, process the data within there, and then provide the result to the application or customer. So how we can write this MapReduce, how we can process this MapReduce code, how this MapReduce actually working, what are the various steps related to the MapReduce, that we will discuss in our detailed training environment as well. Now, these up to this point, we have got some idea about the basics of Hadoop, or just an introduction to Hadoop only. Now, if we move towards some kind of associated technologies which are there to help us and which are there to make our task much easier, these are the called as Hadoop ecosystem. Okay, so there are a couple of Hadoop ecosystem that we will discuss in our detailed training environment also. Let me give you some basic idea about some of them. There is something called as YARN, that is yet another resource negotiator. So guys, you can understand this point very well. The thing is like in our today's environment, if you look at the today's application scenario, it is not only like you will be getting a website and informative website kind of that. No, okay. It is something like that. If you have a website, if your company has a website, it might be having some e-commerce portal also, right? It might be having some kind of chat with our customer representative. So all these kind of different kind of requirements are supposed to be implemented on environment, on the cluster environment. It requires a lot of different servers as well, right, for the security purpose. So the technology actually, or the ecosystem that actually manages all these storage parts or storage systems on different servers environment, and this is called as your yet another resource negotiator. Okay. Similarly, we have HBase, Hadoop base. Okay, that is basically a columnar database or a column-oriented NoSQL database. So far, I believe you guys have heard about, worked on, in fact, SQL databases like Oracle, like SQL Server, like DB2, and so on. But this one is a NoSQL database, right? So there are four families of NoSQL database. These are column oriented, these are document oriented, these are key value pairs, and these are graph database. So HBase is considered to be a column oriented database. We will study that, like how you can work upon the HBase and how you can process the data over there. Right. Similarly, we have something called as Hive. Hive is basically a data warehouse solution for the big data within the Hadoop environment. You have a database, now you have a data warehouse as well, and this helps you to work upon with a kind of a programming language that is called as HiveQL, which is almost very similar to the existing SQL programming language. Now we have Pig. Pig is a programming language as well, just like a Java, C++, or C Sharp, or something like that. But the main difference is that this Pig is basically a functional programming language, and whatever the functionality, we realize in around 4 to 5 hours, something like that, or 4 to 500 lines of code. The same functionality we can create just within 15 to 20 minutes and just with 5 to 8 lines of code using Pig. And it will be great for you to know that the Pig was actually developed by Yahoo, and even in today's environment, around more than 40 percent jobs which are running on Yahoo, these are actually running on Pig over there. Okay, so one more thing, guys, I would like to share with you that during this training environment, it should not be something like I will be giving you a PowerPoint presentation and you will be listening to that. It's not like that. It will be a kind of full demo or full hands-on training. Only a few part of this will be a theoretical scenario, but you are supposed to complete a small project on almost all these kind of ecosystems one by one. You will be getting a project on Hive, you will be getting a project on Pig, you will be getting a project on HBase, you will be getting a project on other ecosystems as well. You might be getting a project on combination of all of them, something like that. You might be getting a project on something where you have to decide which ecosystem is supposed to be used. Okay. Now moving forward, there is something called as a scoop. So guys, I hope you know very well that our current data is actually present in Oracle or SQL Server or MySQL databases. Now the question is like how we can migrate that set of data to the Hadoop environment. This is actually done by something called as Scoop. Similarly, we have a Zookeeper. So as you know very well that there are a lot of different servers, right? Like where my data will be deployed, and since this is a very low cost, so client will also not feel any pain for developing a server set or cluster set for you. So the service which actually controls all the servers is called as a zookeeper. Okay. Moving forward, Chukwa and Flu. So guys, as I have just explained you in a previous slide that you can migrate data from external databases like Oracle or a SQL Server or something like that to your this one Hadoop environment. But the thing is, guys, what happens like if you have, let's say, 100 or 200 servers and you need to migrate data within those servers to a single system, right, for further analysis or something like that. In that case, this Flume and Chukwa will come into the picture and they will help you to migrate data without giving you any kind of network congestion, right? Moving forward, something called as Uzi. This Uzi is basically a kind of your, scheduling system, right? Scheduling system or a job designing system, you can also say. Right? Let's say you have a question, something like that. You have some set of data. You have to, process that data through pig. Then the result of the pig should fed to the hive, and then should be processed over there. After that, the result should be used with the HBase or something like that. You have to design a kind of workflow. You can do the same with the help of Uzi. Similarly, we have Mahout. Mahout is basically a kind of machine learning algorithm, or it's a kind of you can say for further data analytics if you need to go for. This is required over there. After that, we have Cassandra. Cassandra is again a kind of columnar database. Okay, and again this is a kind of a NoSQL database itself, and we will have it in terms in order to understand some other versions of architecture of other versions of Hadoop as well. There are different versions which are available in the market, like Cloudera Hadoop, like Hortonworks Hadoop, like DataStax Hadoop, like uh, you know one second guys, like your MapR Hadoop version of Hadoop and all kind of like that. So this is entirely different architecture. So as an add-on, we will study about the Cassandra as well. So apart from all these ecosystems, there will be some administrative activities that also will take place in during our training. So in that case, we will study about how we can install Hadoop, how we can create a cluster within the Hadoop environment, how we can add or remove the clusters, how we can add or remove the host, how we can add or remove the services, right? How we can start, stop, or restart the services, high availability, backup, all these administrative activities we will move forward, and based on that, we have to decide our concerned projects also. Okay, so during the training time, you will be given a lot of chance for the question and answers. So if you have any query, any question, you can contact us at Best Price Trainings. Thank you and have a nice time ahead. Bye bye.